Okay, so this is a presentation on wrangling with non-standard data. And the 8 authors of this paper come from 3 very different digital humanities projects whose objects of interest range from modern online forums to 15th century books and personal letters. But what unites all of these 3 different projects are that they each worked on non-standard data and had problems with it. The core of the issue here is that, and this is common to all of science, is that to be able to infer something about reality, the data you use in your research needs to accurately reflect that reality and measure the objects of interest. In traditional branches of experimental science, or for example, social science surveys, there are very standardized protocols and ways and means by which to ensure that your measurement targets the variable of interest and that your sample is representative of the population of interests, and so on and so forth. And you can sort of handle these confounders and biases already when you're designing your experiment or survey, and the types of errors and biases that remain are also relatively well known, and thus you can more easily handle them in the analysis phase of your research. Now, contrast this with the usual case in a digital humanities project where the data isn't gathered directly by the researcher in an experiment or with a designed form, but instead is found data, arises from some longer process. For example, often researchers in digital humanities used digitized historical collection. And if you start to dig a little bit deeper into the process by which those have been derived, you soon understand that it's a very, very long historical process with both sort of physical events as well as format transformations and transitions. And each of these steps that have happened to the data before it gets to you as a researcher is liable to cause biases or errors. This happens with old historical digitized sources, but it's equally a problem with modern found data, such as that gathered from online fora. The forums have usually existed for a long time. There may be changes in the forum structure or the content management system. The moderation policy may have changed during that time. And of course, in any online forum, you also have, apart from the users, which may be your interests, a lot of trolls and spam bots and so on. And all of these will add sort of confounders to the variables and bias to the data that you're trying to draw inferences from. So both historical as well as modern data has biases and confounders already before it makes its way to the researcher for analysis. But there's also a second problem, which is what is in the data is usually are not directly the variables that are of interest in the analysis. So there's a gap between what is in the data and the questions of interest. For example, you just get the forum raw text of the forum posts, but you're interested in the sentiments of the posters or what they talk about, the topics. So usually you then apply some computational processing, normalization, cleanup to the data in order to derive the final data that you sort of base your analysis on. And also this task, it both takes a lot of time, but it's also liable to cause further bias if you are not careful in doing it. So 2 aspects here that cause problems in non-standard data. And in the following, I'll go through both of these in more detail. Starting with the sort of errors, omission, duplication, noise, and confounders in the original data and how this causes bias even before it gets to the analysis environment through examples. And as the first example, here we are looking at data in the digitized newspapers collection of the Finnish National Library. And happily, the library provides metadata on the newspapers in its collections. And for example, for this newspaper, Åbo Underrättelser, it says that the page size of the newspaper is A3. However, if you then actually go into the data, because it happens to have scanning image size information in the image scans, and you just plot the raw page height of the scans, you soon found out that it's definitely not standard A3 size. The A size ISO standard wasn't even created at this time, and furthermore, it's not a single page size. Actually, the page size of the newspaper changes radically through time. Further, while there is this sort of general mainline size for the newspapers, there are also a lot of outliers, particularly at certain periods of time. And then if you dig more into those outliers, you find out that actually the collection, the digitized collection, contains also a lot of other material than the main papers. Sometimes there were late-breaking news, and these sort of late-breaking flyers were attached to the newspapers, but there are also, for example, very long multi-hundred page booklets attached to particular newspapers that have happily been scanned there. So if you sort of try to look at the maximum number of pages for a newspaper, you can come out with an answer of multiple hundreds of pages due to the fact that that's just an outlier. Some booklet that has been published in association with the newspaper has been scanned as an issue of that newspaper. But okay, you can extract the raw page size information from the scanning signal, and you get a much more finer detail through that. But then we did that. Then when we tried to analyze that signal, it looked quite funny. Between 1890 and 1910, there's a weird drop in page sizes, both for Finnish as well as Swedish newspapers. This seemed odd and seemed like it couldn't be a real phenomena, and of course, turns out it wasn't. Instead, because the newspapers have been digitized during a 10-year time span in the Finnish National Library, using in total 22 different versions of OCR pipelines. Here are just the major versions shown. So it turned out that for a particular version of the scanning pipeline that happened to be used to scan the 1890 to 1910, most of those newspapers, the scanner, the pipeline, misreported the size of the pages. So that sort of came out here, but the important point is to again understand that this is really common, that things get digitized in 10-year or more lifespans, and then the errors crop up and the data is by no means uniform. There are further examples of bias in all of the data sets in these three projects and more. For example, in the English short title catalog, which was a historical library catalog of 18th century English publications, there are weird spikes every sort of 5, 10, and 50 years. And of course, these are not real publication years for these books. Instead, they are uncertainly dated books. So they just know that the book was published sometime in the 18th century, and they set the date of publication as 1750 due to that. In the Fennica, Finnish National Bibliography, if you just plot the number of Swedish language books, you find a really curious gap starting at the start of the 19th century. And then when you sort of ask the librarians, they will tell you that this is caused by them just not digitizing yet the Swedish language cataloging cards at all. So the data is just missing. So these were historical data, but these problems of bias and error and noise also abound in modern language data. So here's the Suomi24 internet online forum as it was given to the researchers. And when they looked at the data, they found that there were these weird drops in message numbers in 2006 and 2005, and upon further inspection, these messages were just for some reason missing from the dump. Also shown are many sort of large spikes which show activity of particular spam bots at that time. And there are more and more and many more examples of these kinds of biases all throughout these 3 projects and beyond. So the data is originally already rife with bias, but there's also this the problem of there being a gap between the data and the questions. And there is usually a need of a lot of cleanup and enrichment to be done to the data. And this might also cause bias. Even in sort of relatively straightforward, very well done data, such as library catalogs, there are problems because for example, for library catalogs, the standard for how they are stored comes from the 60s, and material and values are stored just as free text fields. So you end up needing to create a lot of rules to turn this kind of page number information into actual numbers, and you need to map 100 different forms by which you can record that the writer is William Shakespeare into a unified form. This is fine for a single sort of metadata field, but for example, in the Commis project, this has to have been done for more than half dozen fields, and in total has taken tens of thousands of lines of code and multiple years by multiple researchers to do. Then when you get to the sort of old full texts, you often use OCR on them, and sometimes it works nicely, but for other sort of poorer quality microfilms, or for example, Fraktur fonts, which are often used in distinct subparts of the corpus, the OCR can go horribly wrong. Again, because these are distinct parts that will bias your data, it will not be sort of uniformly corrupted. The errors will be distributed in a particular fashion. In fact, sort of when we, in the Stratas project, we were interested in the which social groups innovate language. The data was originally very varied in spelling, so we wanted to normalize the spelling, but then we found out that, surprise, surprise, the spelling of higher ups in social hierarchy was easier to normalize than the spelling of lower class women, for example. So in the end, it turned out that we couldn't use our fancy normalization pipeline actually at all, and instead we had to normalize and filter these by hand in order to create trustable data. So really, coming back to the 2 main points, it really is different from traditional research. You have a lot more biases, errors, and there is also this gap in the data. And these cause an endless sort of cascade and headache of problems. So what to do then with this? We have 3 suggestions. First of all, it's really important just to know that these problems exist. This is important both for researchers who need to plan their projects to take this into account. They need to devote significant resources and time into cleanup and figuring out all the biases and problems in the data. This is also very important that the funders know this, so that when a conscious researcher puts this in this sort of cleanup time in their funding application, the funder will value that effort that goes into cleanup instead of purely analysis points. A second point is that often these are sort of large data sets that are of interest to very many people, but they have particular interest inside that data set. So, and no one will sort of steal your particular interest, but everyone who has a particular interest within that vast data sets needs to do this cleanup. So it just makes sense to share the task of cleanup and do it in a reproducible open science way, open source, using open source tools and so on. Finally, we wish to point out that this bias and confounders and this issue with the data is really prevalent across from historical research to modern social media research, and is an area itself worthy of further study. Thank you.